Hi there, it's Mrs. Lindquist. So now we are going to do part 2, which we're actually going to make some graphs of some sine waves. So example 2 says graph 2 cycles, identify the amplitude, period, and 5 key points. So again, when we look at this, we said our general form is y equals a times sine of b theta. So our a value is going to be 3, and our b value is going to be 1 because there's a 1 theta there. The first thing I want to get is my amplitude, so I know how high my peaks are. My amplitude is the absolute value of A, so the absolute value of 3 is 3. So we know the heights of our peaks are going to be 3. And then our period, the formula is 2 pi divided by B. 2 pi divided by 1. Our B value is 1. So our period is 2 pi. So it'll take 2 pi to do 1 complete cycle of sine. All right, so we're going to look at our table here. So we have theta, which is our x, and we have y. So let's talk about the pattern of the y values. So we know that sine, the pattern is 0, max, 0, minimum, and back to 0. So the normal pattern is the hill and then the valley. So we start with a y value of 0. Our maximum is going to be our amplitude because that's the highest point on the graph. So it goes to 3, and we go back to 0. Our minimum is going to be -3, and then we're back to 0. So that's the pattern of our y values because we know that sine starts with a 0 and ends with a 0. So now we have to talk about what is our range for theta. So we're going to start with 0, and we can finish the whole cycle up by 2 pi. So 2 pi. So remember, we're going to take our period of 2 pi, and we're going to multiply by our 5 key values. So we're going to multiply by 0. So 2 pi times 0 is 0. Then we're going to do 2 pi times a quarter. So that'll be 2 pi over 4, which is half pi. Then we are going to do 2 pi times a half. So that'll be 2 pi over 2, which is just going to become pi. And then our last one is going to become 2 pi times 3/4, which is going to be 6 pi over 4, which reduces to 3/2 pi, or 1.5 pi. Another way to think about this is you can take this 2 pi and split it in half. So 2 pi split in half is pi, and you can split the pi in half. So half a pi is half pi, and between pi and 2 pi is 1.5 pi. So we can label this out. This is theta, this is y, and we'll label out our theta values. So our first one is going to be half pi, pi, 3/2 pi, and 2 pi. And we're going to plot our point. So 0, 0 is going to be the first point on our sine wave. And then at pi over 2, we're going to be up at 3. And again, we can scale this y-axis any way we want, but we'll just say that 3 boxes up is 3. Then we have pi 0. So at pi, we're back at 0. At 3/2 or 1.5 pi, we're at -3. So we will go down to -3. And then at 2 pi, we are back to a y value of 0. So you can see the hill and the valley, and you can draw that in. So this is one cycle of sine. It has a period of 2 pi and an amplitude of 3. They're asking us to graph 2 cycles of sine. So to make a second cycle, we're going to start at -2 pi. And we're going to repeat the same pattern again. So it goes 0, max, 0, minimum, 0. So it should be the same exact pattern of make sure that your graphs look like waves and not spikes. So if they look like they're points, you should round them out. It should look like a soft wave. All right, let's take a look at example B. All right, again, so for example B, our A value is 1 and our B value is 2. So why don't you pause the video and figure out what the amplitude and what the period are going to be. All right, so for amplitude, that should be the absolute value of 1. which is 1. So we know the height of the peaks are going to be 1. And the period is 2 pi divided by b. So in our case, we're going to have 2 pi divided by 2 is just pi. So I can get a full cycle in by pi, which this makes sense. Our b value is 2. I can get 2 cycles in between 0 and 2 pi. I can because they're smaller. It only takes pi to get a full cycle in. All right, so let's make our chart. So we have theta and we have y. So again, pattern of the y's. 0, max, 0, minimum, back to 0. So we start with 0. What's our max? Our max is going to always be our amplitude. So it's only going to go up to 1, back to 0. Our minimum is going to be -1, and back to 0. And now let's look at the pattern of our theta, or our x values. So we start at 0, and it takes pi to complete this full pattern. So we're going to break pi into quarters. So we have pi times 0, which is the pi, and then we're going to do pi times a quarter, which is a quarter pi, or pi over 4, pi times a half, which is a half a pi, and the last one is pi times 3/4, which is 3 pi over 4. So you can see we're just going up by quarter pies. A quarter pi plus another quarter pi is a half pi, plus another quarter pi is 3/4 of a pi, and then we add another quarter pi and we're to 1. So again, we're going to label theta and y, and we're going to label out our thetas by the intervals that we indicated on our chart. So we have pi over 4, half pi, 3/4 pi, and pi. And we're going to graph it out. So we're going to have 0, 0. At pi over 4, we're going to be up at 1. Then we're back to 0. At 3 pi over 4, we're at -1. And we end at 0. So here's our hill, and there's our valley. Okay, and if we're going to do another cycle, we can get one in between 0 and pi. We should be able to get one between 0 and -pi. And you don't have to label all these out again. What sometimes I see students do is they want to make a reflection of this. Remember, we don't want to have this, we don't want to have a valley and then a hill. We're supposed to have a hill and a valley. So we're going to follow the same patterns of our y values. So we start at 0, we go to a max, to a 0, to a minimum, and back to a 0. So there we go. We have our 2 cycles of our sine graph. All right, for example C, go ahead and write down your A and your B value and see if you can figure out your amplitude and your period. So pause the video and we'll go over it. So our amplitude should be the absolute value of -1.5, which is a positive 1.5. Remember, amplitude is always positive. So what about our period? We have 2 pi over b, so we're going to have 2 pi divided by 3. So our period is 2/3 pi, because we are able to get 3 cycles in between 0 and 2 pi. So if we take 2 pi and divide by 3, that shows me that I can get 3 cycles in. Let's take a look at our chart here. How is our pattern of our y values going to be different for this one than it has been for the last 2? How is this negative a value going to play in? If you said we're going to do a valley and then a hill, you'd be correct. So we're going to start off with a 0, then we're going to go to a minimum, we're going to go to a 0, to a max, and back to a 0. So in this case, we're going to go to a 0. Our minimum is going to be -1.5. Back to 0. Our maximum is going to be positive 1.5, and we're going to end at 0. So let's figure out theta. So we're going to start with 0, and we're going to finish the whole thing by 2 pi over 3. So go ahead, and you're going to be doing 2 pi over 3 times 0, 2 pi over 3 times 1/4, 2 pi over 3 times 1/2, and the last one would be 2 pi over 3 times 3/4. So pause the video and calculate those values out. Okay, so 2 pi over 3 times a quarter, that's going to give us 2 pi over 12, which is going to become pi over 6. 2/12 is going to reduce to 1/6 pi. Then we have 2 pi over 3 times a half. That's going to give us 2 pi over 6, or you can think about these 2's canceling out. That's going to be a third pi. And then here, we have 6 pi over 12. That's going to become 6/12 reduces to half pi. And again, if you wanted to cancel out these 3's, you could do that. So there you go. So go ahead and take a minute and make the graph. Remember, at pi over 6, we're actually going down to negative 1.5, to a 0, to a max, and to 0. All right, and if we can get in one cycle between 0 and 2 pi over 3, 2/3 pi, we should also be able to get one in between 0 and negative 2 pi over 3. So go ahead and take this valley and hill and replicate it over here. So your graph should look like this. Okay, so for example D, again, we have an A value that is negative, and this time our B value is half pi. What does that mean? It means I get half a pi cycles in between 0 and 2 pi. Half a pi, 3.14 divided by 2. All right, I'm going to give myself a little more space here. So our amplitude is the absolute value of A, which is the absolute value of negative 3 is, and our period is 2 pi divided by B. So we're going to have 2 pi divided by pi over 2. I don't like to write a fraction on top of another fraction. So how do I divide by a fraction? Well, it's the same thing as multiplying by the reciprocal. So this would be the same as 2 pi times the reciprocal of pi over 2, which is 2 over pi. So when we multiply these out, our pi's are going to cancel out, and we're going to be left with 4. So our period is actually only going to be 4 radians. So this is actually going to be easier for us to make our chart. So if our A value is negative 3, but we know for sine we start with a 0, and because its A value is negative 3, we're going to go to a minimum, back to a 0, to a maximum, and back to a 0. So we're going to have a valley and then a hill. And we know that this whole cycle, we're going to finish it by 4 radians. While multiplying by a quarter, a half, 3/4, and 1 is almost silly here. Because if we break 4 in half, this is going to be 2. If we break 2 in half, this is going to be 1. And obviously we're just counting by 1, so it's much easier. I guess we could have done 4 times a quarter. 4 times a quarter is still going to give you 1. 4 times a half is 2, and so on. So we have 0, 0. This is our theta. So that's one cycle of sine. So probably should label these 1, 2, 3, and 4. And then we can get another one from negative 4 to 0. So 0, minimum, 0, max, 0. And that would be our second cycle of sine. So that's it for making the graphs. Okay, the next lesson will be on cosine. You guys have a great day. Bye.